This question is about pressure and volume. It gives you a lot of information, but when you read through it, basically to summarise it, you have got a space here where you can change the volume, and it's asking you to calculate the change in pressure. Now, this is important. It says the valve is sealed so no air can escape from the pump. So in that case, you need an equation that links volume and pressure. You are given a starting volume here with a starting pressure, and then you are given a final volume there. So if we use the equation P1 V1 equals P2 V2, then you have 3 of your 4 unknowns. So P1 is 1.01 times 10 to the 5 pascals times by 80 centimetres cubed, and you don't need to convert that because both of your volumes are in centimetres cubed, so it's going to cancel out. And then you don't have P2, that's what you've been asked to calculate, but you do have V2, which is 10. So you've got P2 there and times 10, and when you rearrange that, you get the answer 8.08 times 10 to the 5 pascals. And that's logical because your pressure has gone down 8 times. Your volume has gone down 8 times, so your pressure will go up by 8 times because they are inversely proportional to each other. But there are other things that can affect the pressure of a gas, and that third thing is temperature. So for the assumption that you've made about the air, what we must have done to be able to use this equation here is assume that temperature is constant. That's the only reason why you can use that equation. If temperature was changing, then this wouldn't work. But in reality, when you use a bicycle pump, the pump does become hot, and that's because you have friction. So for 2 marks here, it's quite a nice easy question. Friction will get you 1 mark, and then the second mark is for saying that it's friction between the rubber disc and the walls, or between the air molecules and the valve. So being specific about where that friction will happen. Part B, the photograph, which has disappeared, shows a woman using a pump to lift water from a well. We don't need it. State the relationship between work done, force and distance moved. So an easy mark, it's work done equals force times distance moved. And those are the only acceptable symbols, but again, strongly recommend that you just write it all out in words because your writing's not as big as mine. Then it's using the equation, just putting the numbers in. Now you are moving 1.25 kilograms. Now that is not a force. So when you have a mass like that, you need to turn it into a force. So 1.25 kilograms, you multiply that by 10 to turn it into the weight of the water. So 12.5 newtons. And because that's the weight of the water, that's then the force that you have to put in to oppose the weight and lift the water up. So work done is then 12.5, that's your force upwards, times by 8.70. So your work done is 109 joules.